Okay, this is a nice slide to look at, particularly to contrast with the previous slide which you'd seen, in which we looked at a section of ground bone. This is a piece of bone that's been cut in cross-section, and this piece of bone has been decalcified. So chemically, the calcium has been removed, leaving behind only really the collagenous core or structure of the osteoid and the cells, and that enables it to be sectioned thinly, and we're going to look at this and examine it in just a moment. First, however, let's just get oriented very quickly on the slide. So the shaft of the bone is this dark pink staining material. The arrow is following around here, and the central core here is the medullary cavity or marrow cavity of the bone. The material which you can see which stains here is bone marrow, so it's a mixture of adipocytes, fat cells, and bone stem cells that give rise to or blood stem cells, which give rise to all the cells that you find circulating in the blood. Just for your information, the material which you see adherent to the outside edge of the bone here is striated skeletal muscle, which we'll be looking at in a future practical. And then finally, one other thing that I would like to remind you and remind me to take a look at is the connective tissue membrane that lines the outer surface of the bone here, called the periosteum, and the connective tissue membrane that lines the inner surface of the bone here, called the end osteum. Now let's increase in magnification a little and take a look at the bone itself. So here, developing here on this side, we have the bone marrow, and on this side here we have the bone itself. One thing that you can see immediately in the bone marrow are these large open spaces, and this is where adipocytes would have been found. And then the darker staining material you see here are blood stem cells, and indeed you'll see blood vessels, some of these you can see here, that course up and down through the marrow cavity. Please remember that bone is a highly vascular tissue, both the bony substance itself and also the marrow cavity. And here we're going to look at osteonic or lamellar bone as it appears in decalcified stained sections. If you've looked at the ground bone slide at this point, in fact what you see here will be immediately familiar to you. So here we have osteonic bone. Sometimes we can see very obvious looking osteons, and in other places we can see rather complicated what appear to be shapes of osteons, and this really just reflects remodeling that's taken place. The small holes we see here, for example here, this is a Haversian canal. Here are osteocytes in their lacunae which surround this canal, enclosed in their bony lamellae. Here we have larger canals. These may in fact be either larger canals or remodeling complexes as a blood vessel here. And here we see some fairly fat looking cells sitting on the surface. These are either bone lining cells, or if they're actively engaged in bone secretion, these are osteoblasts. On the outer surface of the bone here we can see a layer that's composed both of cellular, judging by the cell nuclei, and also acellular collagenous material, and this is the periosteum, the connective tissue membrane that lines the bone surface. The innermost layer of cells, which we see here, are bone lining cells, and some of these remaining cells in the periosteum can differentiate into bone lining cells in the event that the bone is damaged. One thing to be aware of is that not all the osteons will be oriented in exactly the same direction, and as a consequence some of the section will cut obliquely through osteons. So we'll see Haversian canals that look perfectly circular. We may see canals like this, which may represent either a Haversian canal cut in partial longitudinal section, or indeed this may be a Volkmann's canal, one of those canals that connects adjacent osteons, or perhaps this one here is a Volkmann's canal. And here again is an opportunity to see, this is the bone marrow. The large spaces are where fat cells would have been present, and the smaller dark staining nuclei here are the stem cell population for all the cells that give rise to blood cells. So it would be good if you can, at least in your head, compare and contrast this appearance of decalcified hematoxylin and eosin stained bone with the ground bone specimen you've seen before.